This advert for this padlock says that there are 10,000 possible combinations. So is that the case? And how could we work that out? That's what this video is all about. So there's 4 possible options, 4 dials that it could be on this padlock. To work out a shortcut of working this out, I'm going to consider just 2 dials to begin with. So I'm going to consider a simplified case. So let's consider what would happen if there were just 2 dials. So if the first dial was a 0, then the second dial could be a 0. So we'd have 0, 0, or it could be a 1, could be 0, 1, could be a 2, could be a 3, and so on. So there are 10 different options that it could be if the first dial was a 0. And there are also 10 different options that it could be if the first dial was a 1. There are 10 different options it could be if the first dial was a 2, and so on. So this gives me my shortcut, because there are 10 different options that it could be for each digit of dial 1, of which there are 10. So 10 lots of 10 is 100, which makes sense here because we can see hopefully that there are 100 numbers in this grid. We can see that goes up to 99 here, not forgetting the 0, 0. So all that together is 100 different options. So my shortcut for 2 dials was just to do 10 times 10. So what about if there were 4 dials like there was in that padlock? Well, let's consider it with this table I've drawn out here. For the first dial, there are 10 options that could be. For the second dial, there are 10 options that could be. For the third dial, there are 10 options, and for the fourth dial, there are 10 options that there could be. To work out the total number of different combinations there could be, all I need to do is multiply those together. 10 times 10 times 10 times 10 is 10,000. So that advert, when it claimed that there were 10,000 different possible combinations for that padlock, that was correct. Now that's a simple example. What about if we make it a little bit more complicated? What about if we put some extra restrictions on this? What about if we said that each digit had to be a different number? Well, the first dial, there's still 10 options that could be. The second dial, now we know that there were 10 options to begin with, but now we also know that it can't be the same as whatever the first dial was. So for example, if the first dial was a 9, the second digit can't be a 9. So that means that there's only actually 9 options for the second dial. The third dial, again, there's 10 to begin with, but it can't be the same as the first dial, and it can't be the same as the second dial. So that means there's only 8 other options that it could be. And the fourth dial, there would only be 7 options that could be, because it can't match the first, it can't be the same as any of the first 3. So to work out what that would be in total, all I need to do is times those together, and I find that there are 5,040 combinations that there could be where each digit is different. What about this one? It says, what if the second digit is odd and the fourth digit is a square number? So that means that there's no restrictions on the first dial, so there's 10 different options for the first dial. The second dial is odd, so that means it could be a 1, could be a 3, could be a 5, could be a 7, or could be a 9. So there are 5 different options for the second dial. The third dial, there are no restrictions on that one, so there's 10 options that could be. And for the fourth dial, it has to be a square number. Remember, the square numbers are 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and so on. So, of the numbers 0 to 9, the only square numbers are 1, 4, and 9. Those are the only 3 possible outcomes for the fourth dial. So, timesing them together, I find that there's 1,500 possible combinations that have these restrictions. Now, we need to be careful with this method. We need to be careful of duplications. So, what I mean by that is, I've got an example here. It says there are 10 students in a class. How many different ways are there of me selecting 2 students? So, for the first student, there are 10 students I could pick from for the first student. For the second student, now obviously I've already picked 1 student, so I can't pick that student again. So there's 9 different students I can pick for the second student. So you might think, oh, it's going to be 10 times 9. There's 90 different combinations that there could be. But let's think about this a little bit more. If I picked student A to begin with, and then picked student B, that's one of these 90 different possible combinations. But I could also have picked student B first and student A second. That is another of these 90 possible combinations. And these 2 outcomes are actually exactly the same. I end up with the same outcome. If I pick student A first and then student B second, I end up with student A and B stood in front of me. Or if I pick student B first and then student A second, I still end up with student A and B stood in front of me. They're the same. It is a duplication. So actually, I shouldn't have 90 different combinations, because half of those are duplications. So actually what I need to do in this example is divide it by 2. And now I can find that there's only actually 45 possible different combinations in this scenario. So what you always need to do with these questions is think carefully. Do these outcomes, are they the same duplication? If they are, divide by 2. If they're not, if these actually represent 2 different things, then you won't divide by 2. Let's have a look at a few more examples to hopefully make that clear. So, there are 30 students in a class. 13 of them are boys, 17 of them are girls. Number 1. How many different ways are there of me selecting 2 students to play a game of chess? So, student number 1. Well, there's 30 different students I could pick from for that. Student number 2, there's 29 different students I can pick from, because obviously I can't pick the same student. They're not going to play against themselves. So, if I multiplied that together, I get 870. Now I need to consider at this stage, can we have duplications? If I pick student A first and student B second, is that the same? Is that the same outcome if I picked student B first and student A second? Well, in this scenario, yes, they are exactly the same. Once I put the chessboard in front of student A and B, it doesn't matter which one I picked first. So student A and student, so in this case there is duplications. These 2 things are the same. So I have to divide by 2. And I find that there are 435 different combinations of students that could play that game of chess. Question 2. How many different ways are there of selecting one boy and one girl? Okay, so there are 13 different ways of me selecting one boy, and there are 17 different ways of me selecting one girl. So 13 times 17 is 221. Now I need to consider whether I could have any duplicates. If I picked student A here and student B here, could I do that the other way round? Well, in this scenario, no, I can't, because remember that these are the girls. And if I have to select one boy here, I can't pick student B. I can't pick this girl in this in the boy category here. So there's no possible way of me getting duplications here. So no, I'm not going to divide by 2. There is 221 different ways of doing this, because those 221 different ways are all different. There's no duplications. Question 3. If every boy shakes the hand of every other boy, how many handshakes would there be? Okay, so the first boy to shake hands, there's 17 different ways of me picking him. The second boy, there's 16 boys left to select from. 17 times 16 is, bear with me, 272. Now I need to think about duplications. Student A, student B. Can I swap these around? Well, yes, there's nothing to stop this student B here is a boy. There's nothing to stop me picking him first and student A second. So I can swap those round. Are they the same? If I pick student A first and student B second, is that the same as picking student B first and student A second? Is that the same handshake? And yes, it is. It's still the same 2 people shaking hands. So that is a duplication. So I have to divide by 2. And I find that there is 136 different combinations of boys that could shake hands. And finally, question 4. A prefect and a deputy prefect are to be selected. How many different ways are there of doing that? So, for the prefect, there's 30 different students in the class that I could select from. So there's 30 students that could be the prefect. And there are 29 students that could be the deputy prefect, because I'm not going to pick the same student to be prefect and deputy prefect. So, multiplying them together, I get 870. Now I need to consider, could there be duplications? So if I picked student A to be the prefect and student B to be the deputy prefect, is that the same as me picking student B to be prefect and student A to be deputy prefect? No, that's not the same situation. I have the same 2 people stood in front of me, but in this case they're doing different roles. So in this case there is no duplication, and so I'm not going to divide by 2, and so there are 870 different ways I can select that prefect and deputy prefect. So there we go. This is the product rule for counting. We work out how many ways there are of doing one thing and another thing, multiply them together, and then consider whether there are any duplications or not.